I'm Henry Gilliland, the motion specialist with ES&E. Tuning servo motors can be nerve-wracking and often seems extremely complicated and difficult. However, I'm going to show you how simple tuning can be when you're using Rockwell Automation's integrated SIP motion over Ethernet IP. In this series of videos, we'll examine 3 different methods that you can use to achieve a stable and precisely tuned position control loop for just about any positioning application. In this video, we're going to be building a trend in Rockwell's Studio 5000 Logix Designer that we will use throughout the tuning process. Let's dive in. Here we already have a pre-configured SIP motion axis in Logix Designer. With any servo tuning, the first step is always going to be to create a trend to monitor critical data that the axis provides. In version 31 of Studio 5000 and above, trending can be found in the Assets folder. Right-click on the trends and select New Trend. Give the trend a name and select Next. Now select each tag you want to monitor in the trend. For tuning, we'll be watching 4 important tags that tell us everything we need to know about the axis in question. Select Actual Position, Actual Velocity, Current Feedback, and Position Error. Then click Finish. The trend is now ready to run. However, the data shown using the default settings isn't very useful. We'll need to scale things properly before we can use it for tuning. To do this, we'll need to examine the scaling of the axis we're tuning. Double-click on the axis or right-click and select Properties. Open the Scaling menu in the Axis Properties. Take a look at the programmed units. In this case, they are millimeters. Then look at the range and limits to help you determine how to scale the trend. Click OK. Then right-click on the trend and select Chart Properties. In the Chart Properties, select the Pins tab. In this tab, we will set the range of each tag we are looking at. First, set the pin widths to 2 to make them easier to see. Then set the ranges. In this case, we have a minimum position of 0 millimeters and a maximum position of 150 millimeters. Set the max and min velocity for the axis. This is displayed on the trend in units per second. So in this case, millimeters per second. Current feedback is displayed as a percent of the motor's continuous current rating. Use -100% to 100%. Position error is displayed on the trend as units, here millimeters. We'll start with -1 millimeter to 1 millimeter. Next, select the X-axis tab. Change the time span to 10 seconds so we can see more data at one time. Click Apply to see changes so far. Then select the Y-axis tab. Select the preset option to use the range values we entered in the Pins tab. Click Apply to see the ranges change. The chart should now reflect the values that were entered earlier. Change the number of decimal places shown to 3. This way the data readout is more precise. Then select Isolated Graphing to separate the 4 graphs and click Apply. Now we clearly see and easily understand the data we're viewing. This graph more accurately represents an axis that is sitting perfectly still. However, the data from the current feedback and position error tags is still not being displayed. The data will be blank until we enable it in the Axis Properties. Open the Axis Properties and select the Cyclic Parameters menu. Note these settings can only be changed while the axis is not running. Under the list of parameters to be read each cycle, click the checkboxes for Current Feedback and Position Error. Then click Apply. Note the real-time data is now showing in the list. Click OK. Now, using motion direct commands, we will run the axis and observe. Right-click on the axis and select Motion Direct Commands. This tool allows you to manually manipulate the axis using SIP motion commands. We will select the MSO or Motion Servo On instruction and click Execute. It's clear from the oscillating current and noise from the servo motor that the axis is poorly tuned. Now that we have completed setting up the trend, we are ready to properly monitor and tune our axis of motion. We will continue on with 2 different methods of auto-tuning the axis in the next video. Thanks for watching, and please be sure to subscribe to ES&E TV for updates on all the products and services that we offer.